Ladies and gentlemen, welcome to our first lecture of data analysis, which is not on the 3rd of March, but we'll accept that. First lecture will be more organizational aspect. As probably most of you know, my name is Jerzy Baranowski, and I have the pleasure of being head of Laboratory of Computer Science in Control Management. We reside on the 2nd floor. You can find me in room 214, where we probably, someone wants something from me, can find. If not, you can reach me by email, or if you really need to, by Teams. My email is jb@agh.pl. As I mentioned before, course materials will be available on GitHub, and those will be, of course, laboratory exercises and probably slides. This is something that is still a bit undefined at the moment. Today's slide is less relevant in this aspect because it will be more general stuff and general discussion of what is going on and stuff like that. But in future slides we'll see, because I've previously tried to use directly Jupyter notebooks for slides, but I wasn't really pleased with the results, so we'll see how it will work. Okay, now is the issue. The issue is that syllabus system at AGH is so magical that our course has two independent syllabus instances, and when they gave me editing powers before the semester, they directly showed me it directly moved me to one of those courses and for the next semester, so in 2023. So what is in current syllabus is not up to date. These are not big differences, but I will try to cover it here so everything will be generally clear. So, during this course, you will be doing both laboratory exercises and exam. So let's start discussing about the laboratory exercises. Laboratory exercises are graded on the base of the project that you will be realizing in the second part of this semester. First, we'll have some exercises to get you familiarized with ideas, and then you will start doing your individual projects. So, generally, in order to get a pass, you have to pass laboratory exercises. So you have to send the reports from the classes. Then you need to provide your grade will be based on the project. So project has to be positively evaluated, and you will have to assess 2 projects of your colleagues. So this will be an exercise in mutual grading. The projects will be realized in the group of 2 people, so we will be splitting the half semester into 2-person groups. Then, after you complete this project, it will be submitted for grading by me or my colleagues, and to 2 other groups of students, which will be assigned randomly. And we all will be grading the project using a checklist. We will provide a checklist, what needs to be done in the project, and your colleagues and we will be evaluating the project based on that checklist. So that will be depending on the final grade. However, dishonest grading, so in a situation generally when our grade is significantly different from your colleagues. So let's say that you give your colleagues all max scores or all negative scores because you don't like them. Then we will disregard that grade, of course, and your grade will be reduced. So just be honest. Do your grading honestly, and there will be no issues. the final grade of the course will be based on the laboratories and on the exam. And it will be an average of all your grades that you received for laboratories for the exam. So, if you pass at first attempt, both laboratory exams, you will have only 2 grades to be averaged. If you fail, you pass the laboratory first instance and you fail first attempt at the exam, then to the final grade will be sum of all laboratory grades, 2.0 from the first exam, and the positive result from the second exam. So, as you can see, multiple failures reduce the scale of possible final grade. So, just to be aware that those, of course, even if the average is positive, you still have to pass both exam and laboratories. So, if someone has 5 from laboratories and 2 from the exam, they do not pass the course because they have to pass the exam. Generally basic stuff, but I want to have to. The exam is, if you have numerical methods with me, it will be in the same form. So you will be answering orally, preferably in person, but because of this games for dictators that will be in Krakow, probably might be more difficult, so perhaps it will be online. Either way, to attempt the exam, you have to pass the laboratory, so you have to pass the projects. You will receive the list of topics at least 2 weeks before the exam. And they will be more or less general topics that you need to explain what is going about. As if someone has not an exam with me, I never require direct formulas, I don't require specific algorithms, but I ask more about the understanding of the subjects. So if the question is more general, I require to know what you generally know about the aspect. As usually, you will be answering 1, 2, 3 questions, preferably 1, and then you pass. If you fail the first questions, you will receive more questions until either you fail to or pass to. So, generally, in case of missing the first question, you need to answer positively on 2. Clear? Okay. I will copy all the results from the syllabus into the UPO platform, so it will be available, so it will all be cleared. Okay, so the course is generally divided into 2 parts. The part on the laboratory is one thing, but generally the topics on the lecture will be divided in 2 parts, which will be covered in more or less this order, which I'm not sure yet, which will be finalized. Today we will discuss about some introduction to the statistical modeling, what is going around, why we are doing that. We'll explain what is going on in Bayesian statistics and why it's important or not. We will describe some models of likelihood, how to model our prior knowledge about the process, and explain how the probabilistic computation works that allows us to do that, all that computation. After that, we will move into some example models, so model types that we can handle, general idea of Bayesian workflow, so how to create and critically analyze your own models. We will address aspects of causal analysis in some way, hopefully, and hierarchical and multi-level models, which allow you to model group behavior between multiple, connection of multiple, let's say, combining multiple models into one. And finally, we will do something about model checking, some methods of how to verify will our model generalize. So it will work for new data, especially in the presence of lack of data, and how to compare multiple models between one another to get good results. And besides the fact that I will be giving you lectures, you are very encouraged to familiarize yourself with some material. Our main course book is Bayesian Data Analysis 3, like a third edition by Andrew Gelman and Associates. This book is a main course book because it's free. So you can legally download it from the publisher website, and that is mine. The book is okay. It's a bit dated because it was written when there was much less possibilities of efficient numerical computation of statistical models, and that makes that generally really causes it to include more of analytical results. Certain ideas are only mentioned, how they should be working, but it's not terrible book, let's say, and there are a lot of resources for that. There are exercises for that book. There are additional lectures that cover topics as they're in the book directly. Those are lectures by Professor Aki Vektari from University of Aalto, and I recommend them if you have some time to watch because they can be interesting. However, there is a focus more on, again, analytical computation, which has certain limitations. Better book, and generally very good book, is Statistical Rethinking by Richard McElrath. And this book, however, is not free, so I cannot recommend you to buy it directly and work on that. But this is a very good book, especially if you want to learn by yourself, because it's a book organized as an individual course that you can just follow examples using code provided. So instead of formulas, there is much more code that you can use. However, this code is in R. It is translated by multiple people to different languages. So there are a Python version, Julia versions, multiple frameworks different used in it. So this is very popular, and also it has its own YouTube lectures available, which are freely available from the author, together with slides from those lectures, but the book isn't. So this book is based on computation in R and on a special toolbox or package created in R by the author, which has certain limitations because of that, especially in general. And this was a book written not for engineers, but more for biological and social sciences. Because, which we mentioned today, later today, the main ideas and main results in statistical modeling really were created in those areas. Because people in biological and social sciences do not have physical model based by laws of physics to rely on when you model the phenomena you're working with, so they have to create some kind of way to incorporate our general uncertainty about how everything works. Finally, another free resource available from the website of Michael Betancourt at beta and alpha github.io, and he has this is a book in progress, really. It's a book in progress in form of, he calls them case studies. They are not really case studies, they are more or less becoming chapters describing modern probability theory in concept of statistical data analysis. However, it is very theory heavy at certain aspects. It uses specific language that comes from the fact the author is a physicist, and they use special notations, special language that's not necessarily clear and translatable to Polish easily. So what is there is the most modern stuff, really, because it's being created based on not on focus on the student, but more on practitioner part, and it's based on the higher entry-level difficulty, So that's a problem. But on the other hand, there are things about Monte Carlo computation that you can find nowhere else, and these results are very helpful to understand certain stuff. There are some things that might be a big barrier when you start reading it, but there are some very good stuff. So those three resources I will be using most during this course. However, there are some other things that you could get yourself familiarized with. One is the book by Ben Lambert called A Student's Guide to Bayesian Statistics, which is, let's say, a second modern book of Bayesian statistics. Because there are lots of classical books which I do not recommend because they do not really translate to modern tools very well. However, two books were released a few years ago. This was Statistical Rethinking by McElrath and Student's Guide to Bayesian Statistics by Lambert. It's more traditional course book type, but also not freely available. And while you can find Springer books online in multiple places, this you can only find in scanned form, and this looks horrible. So just for really determined to learn, but also has some YouTube materials. So it's not a bad book, but just for more interested. There is a book that you can find rather easily, which is called Bayesian Analysis with Python. And I do not recommend it, because this is a book that, well, the advantage is that it's directly in Python. It's based on the PyMC3, now PyMC without a number, library for Bayesian computation. However, this is a book that gives you just enough information to hang yourself. Because you'll be able to specify the model, but you will have no idea how it works, why it works, and what kind of implicit assumptions you do during that. So this is a rather risky choice for first contact, but people use it. It's very heavily based on PyMC and RVis packages in Python. We'll be using RVis because it's useful, but generally this is a book for someone that already understands what's going on and wants to familiarize themselves with PyMC. And if you know PyMC and want to more, this is by the same author and colleagues. There is the Bayesian Modeling and Computation in Python. This is most recent book on Bayesian analysis, but still it's very grounded in PyMC. This one is freely available as a Git book, so you can find it on online, an applicable version. And it's not bad, but again, it's more. You will have more problems. It won't be that easy to learn how something works. You may be more able to how to use certain, especially Python-based tools for work. You can additionally exchange. Let's say, extend your knowledge by using social media, because maybe surprisingly, statistical community is very active on social media, much more than other engineering fields. Machine learning and statistics are very active, especially on Twitter, but we'll see what happens with Twitter later. But Mastodon didn't pick up, so perhaps Twitter will stay to go. Professor Aki Bektari, I mentioned before, he's on Twitter most apparently, that's why I've provided the link to Mastodon. He has a very big output of new statistical modeling and machine learning results, because his group in Alto on probability machine learning is very active, so I strongly recommend following. Michael Betancourt, which materials I mentioned before, also is available on Twitter, can be interacted with, and also provides on Twitter a lot of threads that kind of supplement the information that is given in this in his studies. So this is not a bad person to follow. Richard McElrath as a source to get information when the new lecture editions of statistical thinking will come, and some about his recent work. He actually works in the anthropology department in Germany, and he's teaching people statistics around the world. He also shares a lot of pictures of him cooking with his cat. So for people interested in Steve, this is the stuff that people like. And finally, Alexandra, who is one of the members of PyMC team. And I recommend him because he has a podcast on learning Bayesian statistics, which is not a bad thing because you can. There's a lot of talks with people who are doing Bayesian analysis in real life, in real problem companies, in universities, and they do not go very deep technically, but they explain how certain things work, what's good. So this can be a good resource. There are like a 50 plus episodes of this podcast. Each of those has about a 1 hour discussion of certain applications, like in elections, in speech recognition, in anthropological studies. Could be an interesting listen. And it, however, contains a very cringy hip-hop song about using Bayesian statistics, and well, at least for me it's very cringy, but it is what it is. Either way,